Hello, we are 91A1N, a VEX Middle School team from Seaquam Robotics. My name is Krithik.
My name is Carter.
My name is Owen.
And my name is Trevor.
We have two basic functions used in our autonomous. The first function is intake with int left and int right. This function tells the front intake motor to spin at the provided voltage. The second function is set roll with int left and int right. This function is the same as intake except it is for the rollers instead of the intakes.
We use unpowered wheels with shaft encoders called tracking wheels to measure how far a robot has traveled instead of the built-in motor encoders. We find this to be much more reliable while using an X-drive. These tracking wheels are mounted on a joint, so that even if the robot lifts off the ground a little bit, the wheels won't lose traction and become inaccurate. We also are using the measurements of the shaft encoders as a gyroscope. By using an equation, we can find the robot's current heading at any time. Our robot uses a Ploop to get more accurate driving in autonomous. A Ploop is a feedback system that allows for the robot to automatically fix mistakes. Our Ploop uses the values of our shaft encoders and compares them to a defined target value. By doing this, it can set the voltage of the motors based on how close or far the robot is from the target. In our autonomous, we run the Ploop as a separate task so that the robot is always trying to stay on target, even if a different function is running. We are also planning on implementing an absolute position tracking system known as ODometry. This system uses 3 tracking wheels on the robot to calculate the robot's position in a Cartesian coordinate plane. As this code is quite advanced, it may take us a large amount of time and effort. For the next version of our robot, we will be making much greater use of sensors. We are planning on not using our tracking wheels to get the robot heading, and instead we will be using the inertial sensor as it will be more accurate. We are also planning on using ultrasonic sensors to detect when and where balls are in the robot. This will allow us to run a function that will automatically move balls into predefined locations. By doing this, we can increase the speed that we score towers.
We claim the first tower with the pre-loaded red ball and do a 170-degree turn to score the 2 red balls into the second tower. After backing out of the second tower, we move to the third tower and score the red ball that is in front of the third tower. Then we back out and do a 160-degree turn to score the red ball in front of the fourth tower. Lastly, the robot scores the last red ball into the top right tower.